class, I'm Isaac, your mathematics teacher from Smart Online. I'll be teaching you each topic, and before you go, subscribe to our channel and press that notification button so that you'll be notified for every video that we are going to be uploading. So let's go to class. Hi class, we are going on approximation 2, which is decimal places and percentage errors. An approximation helps us to see and understand easily the size of a number. It is a number taken as close as possible to the actual value of the number. In order to come close to the actual value, the number must be rounded off. This implies digits 1 to 4 are rounded down, that is going to be rounded to 0, while those from 5 to 9 will be rounded up to 1. That's what we are saying. Other methods could be approximating to decimal places or significant figures. Decimal places mean the number of places after the decimal point, while significant figure is the first non-zero digit from the left. Are you following? Let's move on. Now let's go to examples. Example number 1. The distance between Earth and the Sun is 148729440 kilometers. Round this number to the nearest million, nearest two significant figure, nearest three significant figure. So now let's move on. Now solution. Hey, 148729440 kilometers to a million. You are going to start from right. This is not a significant figure. You are rounding it up to, you are approximating to a million. You are rounding up to round this number to nearest million. So no, this one is not significant figure. Specifically, it's just to a million. And how many digit figure is in a million? And in a million is 6. That means you are going to count 6 from right, which is 1, 2, 3, 4, 5, 6. So 6 falls to 7, and that means you are going to round 7 up and then add 1 to 8. Are you getting it now? Add 1 to 8. So that is, the other will turn to 0. That is now going to be 148 plus 1, which is 149 0 0 0 0 0. This is the answer that we're talking about. That is, you round it up to, you round 7 up. Are you following now? So let's move on. Now you round it up to nearest two significant figure. Now I want to tell you two significant figure here. To be, you are starting, if it is significant figure, you are starting from first non-zero digit. Remember this statement. Significant figure starts from non-zero digit, first non-zero digit. And what is the first non-zero digit in 148 in this number? Is 1. So you are now going to, they now said to two significant figure, you just count 1, 2. That means all others will be 0. Are you following me? And you know that 8 is closest to 4. That means you are going to round 8 up and add 1 to 4. It's not going to be 1, 5. All others will be 0. You see the difference between rounding up to the nearest million and to the nearest two significant figure now. So when you are doing to the nearest million, you are starting from right, counting. Are you getting it? when you are doing significant because you are starting from left, that is from left. Are you seeing it? That's what I want to trace out. I want to trace out your confusion. So please, I want you to take note of those that I'm telling you. Now, that is, you round 8 up, and this 8 you turn it to 1, and then you add 1 to 4. That is why we get 1500. Now let's go to the third one, which is 3 significant figure. Now, to 3 significant figure, that means we are going to count from the first non-zero digit, which is 1 here. You are saying 3 significant figure, you have 1, 2, 3. So any number from this place will be 0. But you know that you are going to round 7 up, and 7 is greater than 5. That's why we round it up. If it is less than 5, we are going to round it down to 0. But now we are rounding it up to 1, and then you now going to add that 1 to the closest number to it, which is 8. That means 8 will turn to 9, and others will turn to 0, which is now going to be 14900. That is why we get this one. Because we are rounding up 7. I think you get this. So let's move on. Now write 78.45831 kilogram to, that is example 2 anyway. Remember, we got 1, 2 decimal places, and then remember we got 2, 3 decimal places. Get this right. We have defined decimal places to be number of places after the decimal point. Are you seeing it now? Don't forget that. And in this example too, that's what we want to do. Are you following? This example too, that's what we want to do. I want you to get it right, and then you'll be able to do any question of this manner. Now, when you want to, they say you should write this number, you write it to 2 significant figures, which is number 1. 2 decimal places. Then you start from decimal. You count 1, 2. Then any other number will be rounded up to 0. You understand now? But 8 that is close to the last number, which is 5 here, is greater than 5. So you now round it up to 1 and add that 1 to 5. It's now going to be 78.4. This 5 will turn to 6. That's what I want to tell you. If you are rounding up to 3 decimal places, you are going to start immediately after decimal. 1, 2, 3. Are you following? Let me clear this so that you get it. Now, number Roman figure 2. Now you are rounding this up to 3 decimal places. Are you following? You are rounding up to 3 decimal places. Now you are now going to start from decimal point. I'm going to say 1, 2, 3. So these ones are value of interest to you, while the rest are not. So this is the rest that you are going to turn to 0. However, the 3 that is close to the last number, which is 8 here, is less than 5. That means you are going to round it down to 0. You are now going to add 0 to 8, which is 8. So that is why you get the answer. So let's move on to get the solution at the other side. At the other side, let's go on to get the solution at the other side. Let's move on. Now, which is this? That's why we get 78.46 that I've told you. That's it. Let's move on. If you are rounding it up to if you are rounding up to 3 decimal places, you are going to get 7, 8. This question. Now I'm going to count it 1, 2, 3. That's what we have done. So this one is less than 4 or 5, then it's going to turn to 0. You round it down to 0 and you add 0 to 8. 8 remain 8. That's why you get 78.458 kilogram. That's what we are saying. Let's move on. Now, number 3, example 3, round 0.0004996 to Roman figure 1 significant figure 2 significant figure. Now, don't forget that significant figure, you are going to start from left, and of course you are going to start from non-zero digits. Now the number started here from 0, 0, 0, 0, but the first non-zero is 4. That is where you are going to begin your counting. Now for number 1, which is to one significant figure, solution. Now to one significant figure, you are going to start from first non-zero digit, which is 4, and you count 1. After that one, all others will be rounded up, but it is 9 that is close to 4, and that 9 is greater than 5. You are going to round it up to 1 and add it to 4. That is, you are rounding up 9. Are you seeing it now? So then 4 will turn to 5. It's now going to be 0.0005. That is why we get this. Are you following? That's why we get that. So let's move further to the next example. Number 2, which is 2 significant figure. Now to 2 significant figure, you are going to start from first non-zero, which is 4. You are going to count 1, 2. Are you getting me? For 2 significant figure, you are going to count 1, 2, and then others from here is rounded down or up, but 9 is very close to the last number here, which is 9, and then you round 9 up to 1, and then add that 1 to the next number, which is 9, and 9 turn to 10, and that 10 you are now going to see 1 0. That 1 will be added to 4, and 4 will turn to 5, and 9 will be 0. You understand now? So this is what I'm saying. When you add 1 to this place, are you seeing it now? You are going to get, as in you had 1 now. You have rounded this one up to 1, and you had 1. 9 plus 1 is 10. Your right is 0, and then you add that remainder 1. 1 plus 4 is 5. Then you write other 0 zeros. That's why we get this one. I hope you are getting this. Are you following now? That's what I am talking about. Now let's move on. Let's go to percentage error. Percentage error. Every measurement, no matter how carefully carried out, are you following, is an approximation, not exactly. No. If the height of a wall is 25 meters, then the true value or actual height is between 24.5 meters or 25.5 meters. That is, we have plus or minus 0.05, which is the range of the differences. The error involved cannot exceed plus or minus 0.05. The maximum absolute error is plus or minus 0.05. Note this. Now, note this, that the maximum absolute error is an allowance within which the actual measurement falls. The range between which actual measurement falls is the maximum absolute error. While relative error is the ratio of the maximum absolute error, which is precision, to the true measurement value. You are going to get it as we move forward. Now let's go to example. Find the sum of 34.25 to first significant figure. This is the first significant figure, and 26, which is 2 significant figure, and then 10, which is 2 significant figure, and leave your answer to a reasonable degree of accuracy. When you say reasonable degree of accuracy, you see the lowest number that is very close to the actual number, the measurement number. Are you following? Let's move on. Now solution. Now the actual values will be this. These are the actual values. Let me tell you, these are the actual values, and I will tell you why they are actual value. You know, you are given 34.25. Now if you have two decimal, this is a two decimal place, that is 0.25. If you have two decimal place, then when you want to, the maximum error for two decimal place will be 1/2. For two decimal place will be 1/2 of 1/2 of 1/100. 1/2 of 1/100, because this 100 signifies two decimal place. Are you following me? And when you do this, you are going to get 0.005. That's why we get 0.005, because you are dealing with accuracy. Then this is a maximum error that is allowed, that is absolute error for 34.27. That's why plus or minus is this. It's either it reduced with this number or is increased with this number. And 26 is 1 over, you know, it's a whole number. For a whole number is going to be 1/2 of 1/2 of 1. I think you are getting this point. 1/2 of 1. But if it is one decimal place, it's going to be 1/2 of 1/10. Are you getting me? That's what I want to actually tell you, so that you know it in case. So now that is why we get the actual value of this. Now what we are asked to do is that you add them together, and then you find the reasonable degree of accuracy. We are going to get it very okay. Now add them together. You are going to get the sum to be 34 plus 26 plus this one. You add all the errors together. When you added all the errors together, 0.5 plus 0.005, you get 1.005. When you add 34.25 plus 26 and 10, you have 70 plus this is plus or minus 70.25 plus or minus 1.005. Are you getting it now? Now it means that you are talking about 70.25 plus 1.005 or 70.25 minus 1.005. That is what they are saying. So the first one is 70.25 plus 1.005, which is now going to be 71.255, or let me go ahead of myself, or 70.25 minus 1005. You know it's plus or minus, which is now going to be, when you subtract, it's going to be 69.245, and then the actual sum will now lies between 69.245 and then 71.255. Hence, the sum of the values to a reasonable degree of accuracy is 69. I've told you to two significant figures. It's 69, which is the lowest number that is closest to 70. The closest to 70 is this. This one is farther than 67, is farther than 69. If you subtract it, 67 is farther than 69. That is the answer. It's closer. Are you getting it now? That's the answer. Let's move on. Note this that I've explained before. Maximum error can be derived as whole. For whole number, what is the maximum error for whole number? It's 1/2 of 1, which is 0.5. I've told you. And then maximum error for one decimal place is 1/2 of 1/10. Are you getting me? Which is 1/0. and decimal maximum error for two decimal places numbers are 1/2 of 1 divided by 100, and so on. This is what I want to show you, and I believe you got this right. Yes, thank you. Now let's go to the formula for percentage error. In measurement we have two. If you just measure it practically, this is the formula. That means percentage error is equals to error divided by the measurement that you measure. Are you following? Times 100. Why? If it is true value, it's now going to be percentage error equals to error divided by true value times 100. Now let's go to this example so that we get the right example. 1. It says give a balance of 1.15 naira to a customer instead of 1.25 naira. Calculate the percentage error. I want you to get it clear, because this one is one of the Waec question. Now this guy mistakenly gave his customer this change, this is the change that he gave his customer, and actually he's supposed to give his customer this one. So that means the true value should be 1.25 naira. Why this is the one that is mistaken value? Are you getting it now? To now get the error, are you following? To now get the error, it's now going to be the error. What is the error between them? Is subtraction. You subtract this from this to get the error. So let's move on. Now the balance that it gave is this, but the real actual balance is at 1.25 naira. Error. What is the error? The mistake that she made is the error is now 0.10 naira. You subtract the actual the value he gave, the naira he gave, from the actual balance, which is now the error is now 0.10, and then according to the formula for this is equal to error over measurement times 100, which is percentage error will now be the error is 0.10 divided by the actual value, which is 1.25 times 100. Are you following now? So having done that, you are now going to get 8%, because when you multiply it, 0.10 divided by 1.2 is times 100. That is times this 100 by 1 here, you get 10, and 10 divided by 1.25 is 8. So the percentage error is actually 8%. Now example 2, a student was asked to correct 0.025392 to two significant figures, gave its value to 2 decimal places. His error is what? Now this boy actually was given this number, and then he rounded it up to 2 significant figures. The first thing is that you are going to do this one to 2 significant figures, and when we talk about significant figures, you are going to start from the first non-zero digit number, which is from here. The first non-zero digit number is 2, and then to 2 significant figures is now going to be 1, 2, and every other one will be rendered invalid. And also, 3 is less than 5, so you cannot round it up but round it down to 0, and we add 0 to 5, then it's 0.0025. Now 0.0025, you will now subtract. What will be the error? You subtract 0.0025 from this whole number. You get it when I get it. Now the value, you are going to get it. The correct value in significant figure is this in 2 significant figure. Are you seeing it now? That's what I got up here. Now, but the error is 0, but the answer is 0.03. Are you getting it? Are you following? It's 0.03. 3. Now we are now going to remove 0.03 from 0.025. Are you following? When you remove it, divided by actual what do you call it? Divided by actual number, which is this one. Now when you do it, you are going to get 0.5 divided by 0.025 times 10, 100%, which is 500 divided by 25, which is 20% percentage error. Are you getting it? He's supposed to get this answer as I calculated it, but he mistakenly got this answer. So the error will now be subtraction from these two. That's why we get the error up here to be subtraction from the value that he got, the measurement value, and the value that is supposed to be. Do you understand now? So, and the formula for it is error divided by measurement. If it is measurement and he was asked to measure to two significant figures, are you getting it now? Instead, he gave the answer. Sorry, let me explain for good. Let me read it again so that I will not leave you to be confused. A student was asked to correct 0.0. Let me do something so that you get it. I'll make sure you get it. I don't want you to be confused, so I'm going to do it all over. So let me do it all over so that you get it. Now a student who was asked to correct 0.02539 to two significant figures gave its value to two decimal places. There was a mistake. He was supposed to round it up to two significant figures, but mistakenly rounded it up to two decimal places. You know, the two of them are different. Now, if he's rounding it up to two significant figures, the answer, which is the actual answer, is given. Correct value is in two significant figures, which is 0.025. That is what's supposed to be, because when you count from the first known zero digit, which is 1, 2, then any other number is invalid, and 3 that is close to this 5 is less than 5. So we round it down to 0, and we have 0 to 5 remain. That's why the actual answer is supposed to be this, but he mistakenly did two decimal places. So, and his answer was 0.03. I will show you if it is two decimal places. You are going to count 1, 2 from decimal 1, 2. That means anything after this is rendered valid. However, 5 is up to 5. You can round it up to 1, another 1 to 2 to get 3. That's why it got 0.03. Are you following now? That's why it got 0.03. Now, having done that, what will be the error? The error will be difference between the number he's supposed to get and the one that he got. Now, what is it going to now be? The percentage error will now be the difference between the number he's supposed to get and the number he got, which is 0.03 that he got minus 0.025. That is the real answer divided by the actual answer divided by the actual. Are you seeing it? Times 100, which is now going to be, when you calculate your mathematics, you are going to get 20%. This is the error of the guy. I believe you understood this. And if there's anyone that is not clear, you can go back, you can rewind, pause. Just make sure you get this. Percentage error is very simple. You can go and check all the past questions. You see that Waec, neco, Jamb, they have interesting percentage error. So we see